All right, so let's do another problem. Okay, let's put that in here. Is it? Okay, here it is. Okay, so what I did here, well, I see that, okay, let me just read the problem first. The problem is two cylindrical tanks have the same height, but the radius of the larger tank equals the diameter of the smaller tank. So if the volume of the larger tank is K% more than the volume of this, wait, okay. If the volume of the larger tank is K% more than the volume of the smaller tank, K equals, okay. All right, anyways. And what I did was they give you these formulas. So here's, they give you certain geometrical formulas. So I know on the SAT here it's just, this is just, we're talking about cylinders here. So here's the formula for the volume of a cylinder. So what I thought of for doing this is I just figured I would just make up some kind of an example based on the information they're giving. So what I'll do is I'm just going to first I'm just going to imagine a small cylinder, right? So I'm just going to try to draw that. I'm just going to make up a very simple case, right? And I'll say that the height, well, they're going to have the same height, both of them. So this small one will have a height of 1. And I will say that this one will have a radius of 1, which is actually, well, I'll just say the radius is going to be equal to 1, right? So then the next one, the next cylinder is going to be the larger one. So let me draw that out. It's going to basically, this one is going to have the same height. So this one will have a height of 1, but in this case, it's going to, the radius of the larger tank equals the diameter of the smaller tank. So this one will actually have the diameter of the smaller tank would be, the diameter of this would actually be 2, right? So the radius of this one is going to be 2, right? Because to get the diameter is 2 times the radius, right? So this one is going to have a radius of 2. So now I'm just going to like use the formula here, right? So we have pi r squared h, right? So in this case, we have pi, and r is 1, so it's going to be 1 squared. H is 1. So it's just pi times 1 squared times 1 is just going to be pi. Then let's do the same thing for the larger cylinder, right? So let me just put the formula down. Pi r squared h, right? But in this case, we have pi times the radius now is 2, so it'll be 2 squared. Keeping the same height, it's 1. So when you work this out, it actually comes out to be 2 squared is 4. So it's going to be, and 4 times 1 is 4. So it'll be 4 pi, right? So the one thing about a percent is that when you want to figure out the change in the percent, it's actually, the formula would be change over original, right, times 100%. And in this case, our change, it's going from pi to 4 pi, right? From the smaller volume to the larger volume. So that would be 4 pi minus pi. And if you thought of the original, I would think of the smaller cylinder, right? Which would be pi, right? And again, this times 100%. And you wind up getting 3 pi over pi times 100%. The pi's cancel out, right? Then you wind up with 3 times 100. So you get the percent is actually 300. So the answer to this is C, 300. So get that one. And that's it. Okay. All right, so we've done another problem.